Welcome back to our unit on probability. Last lesson was like a fire hose of information on tree diagrams and the fundamental counting principle and just all different new vocabulary. Today's a little bit shorter, and we're just talking about conditional probability, which in my mind is something like mathematical tunnel vision. Let me show you what I mean. Conditional probability is the probability of event B occurring given that event A has already occurred. Here's the notation. The probability of event B given that event A has already occurred. It's always easiest just to learn with an example. So let's go to Las Vegas and we'll get ourselves a deck of cards. And just simply, what's the probability of selecting an ace of diamonds? Well, there's one ace of diamonds and there's 52 cards. So the probability of selecting the ace of diamonds is 1 out of 52. Okay, now the ace of diamonds has been drawn. How many cards are left? Well, now there's 51 cards left. So given that the ace of diamonds has been drawn, now we have a new question. What's the probability of drawing a 5? There's 4 5s, 51 cards left. So the probability of drawing a 5, given that the ace of diamonds has already been drawn, is 4 out of 51. Let's try a couple others. What's the probability of drawing a heart, given that the queen of diamonds has already been drawn? Well, we've taken out the queen of diamonds, so there's 51 cards left. There's 13 hearts, so we have 13 out of 51. What about the probability of drawing a jack, given that we've already drawn a jack? 51 cards left, only 3 jacks left, so 3 out of 51. How about the probability of drawing a heart, given that 2 spades have already been drawn? So if we've already taken out 2 spades, there are 50 cards left, and there are 13 hearts, so we have 13 out of 50. Okay, we can also do this with a frequency table. Here we have a table from a local high school, 9th through 12th graders, boys and girls. So a simple probability question would be, if you had to select a student, what would be the probability that you select a boy? We're talking about the whole student body here. There's 736 boys out of 1,465 students, so 736 divided by 1465, got about a 50% shot of selecting a boy. What about selecting a student in the 9th or 10th grade? Okay, so either 9th or 10th works, so we can take both of those groups. We've got 733 students out of 1465 that we're interested in selecting, about a 50% shot. Let's try some conditional probability now. What's the probability of selecting a boy given that he's in 9th grade? So given that, this is where the tunnel vision comes in because we're focused only on the 9th grade. We're only concerned about these 376 students, and of those, 194 are boys. So the probability of selecting a boy, given that he's in 9th grade, it's about 51-52%. What about selecting a girl, given that she's in 11th grade? Again, tunnel vision, we're gonna zoom into 11th grade. We're only focused on these 384 students, and of those, 174 are girls. So we have 174 out of 384, about 45%. What happens if we flip-flop those? Instead of girl given 11th grade, what if we did an 11th grader given that she's a girl? Does it change the probabilities? Let's check it out. We're gonna zoom in on the girls. So now we're only focused on these 729. Still 174 of them, but if you take 174 divided by 729, you get about 24%. So girl given 11th, not the same as 11th given girl. So be very careful. What is the given information and what's the probability you're looking for? I told you this was a quick lesson on conditional probability, otherwise known as mathematical tunnel vision. Good luck and thanks for being here.